to the Chemistry 124 demonstration videos. This video will be involving Practical 2, which is about limiting reactions. During this practical, you will react hydrated copper chloride with aluminium in two different reactions. In the first reaction, you will use the hydrated copper chloride in excess, and in the other reaction, you will use the aluminium in excess. Now, why is this important? Well, when you write out your chemical reaction equations, you normally write them with the ideal stoichiometric ratios of reactants to products. But in real life and in the lab, you don't always have a stoichiometric mixture of your reactants. One of your reactants will be in excess and one of the reactants will be limiting. The excess reactant is the reactant that is left over at the end of the reaction, and the limiting reactant is the one that is completely used up during the reaction. Now this is important because the limiting reactant is what you use to determine the amount of product that forms.
You will be able to monitor the reaction's progress by evaluating the color change occurring in your beaker as well as the formation of solid copper. The aim of this practical is to become familiar with reactions that involve a limiting reactant, be able to identify the limiting reactant based on the experimental results, and to compare the results with the expected theoretical yield by calculating the experimental yield. The following apparatus, glassware, and chemicals will be required. Two 250 cubic centimeter glass beakers for your reactions, one 50 cubic centimeter measuring cylinder, two 250 cubic centimeter Erlenmeyer flasks, and two funnels for filtration, a glass stirring rod, spatula, and plastic weigh boat. You will need the following chemicals: hydrated copper chloride, aluminium shavings, methanol, and 6 molar hydrochloric acid. Be careful, as copper compounds are toxic irritants, methanol is flammable, and hydrochloric acid is very corrosive. These danger signs appear when picking up different chemicals. See your manual for what they mean. Label one 250 cubic centimeter glass beaker as A and the other beaker as B. Weigh approximately 0.50 grams of the hydrated copper chloride directly into beaker A. Record the mass of the hydrated copper chloride in the data report table. Then weigh approximately 0.70 grams of the hydrated copper chloride directly into beaker B. Again, record the mass of this hydrated copper chloride in the data report. Weigh approximately 0.075 grams of the aluminium shavings in the plastic weigh boat and report this exact mass in the data report table. Add this to beaker A. Weigh approximately 0.050 grams of the aluminium shavings in the plastic weigh boat and report the exact mass in the data report table. Add this then to beaker B. Now use the graduated measuring cylinder to measure approximately 50 cubic centimeters of distilled water and add this to each of beakers A and B. Swirl or stir the beakers alternating with a glass stirring rod. The reaction should take about 15 to 20 minutes to complete. As the reactions proceed, record any observations in the data report table. This includes color changes, bubbling, etc. If there's excess aluminium shavings still observed in any of the beakers after 20 minutes, then add about 5 to 10 cubic centimeters of 6 molar hydrochloric acid. Hydrochloric acid is corrosive, so handle with care. Add approximately 1 cubic centimeter portions and stir with your glass rod until all of the aluminium shavings are no longer visible. Weigh the two filter papers provided and record the exact masses in the data report table. You will now need to set up for gravimetric filtration. Fold your filter paper in half and then in half again to achieve this cone shape. Place this cone inside a funnel that's placed in a 250 cubic centimeter Erlenmeyer flask. Swivel your reaction solution and pour this into the coned filter paper. Using 2 times 15 cubic centimeters of distilled water, rinse the beaker and ensure you get as much copper solid out as possible. Wash the copper solid with approximately 10 cubic centimeters of methanol and allow the copper solid to dry for 5 minutes. Repeat this filtration step for beaker B as well. Mark each beaker with your initials, and once the copper solids have dried for 5 minutes, carefully place the coned filter paper containing the copper solid inside the correctly labeled beaker. Place these beakers on the hot plate in your nearest fume hood for 5 minutes until the copper solid is dry. Avoid heating for more than 5 minutes, as this could cause unwanted oxidation of the copper. Do you have any idea of why oxidation of the copper would be problematic for your experiment? Using tongs, remove the beakers and place them on a metal gauze and wait for them to cool. Once the filter papers are cool to touch, weigh the filter papers with their contents and record these masses in the data report table. Discard the filter papers and copper in the waste container for solids that is supplied, and pour your liquid into the supplied waste bottle. In summary, you use these reactions to identify the limiting reactants, and then you use the limiting reactant to calculate the percentage yield.